Hello everyone. Today we are discuss about task assignment and scheduling. Task assignment and scheduling. Scheduling real-time task and distributed and multiprocessor system consists of two sub-problems. First one, task allocation to the processor. The task assignment problem is concerned with how to partition a set of tasks and then how to assign these tasks to process. Task assignment can be static or dynamic. In the static allocation scheme, the allocation of tasks to nodes is permanent and does not change with time. In the dynamic task assignment, tasks are assigned to the nodes as they arise. Different instances of tasks may be allocated to different nodes. Scheduling of tasks on the individual processor and uniprocessor scheduling algorithm can be used for the task set allocated to a particular processor. Static allocation algorithm. The tasks are pre-allocated to processor. No overhead incurs during runtime since tasks are permanently assigned to processor at the system initialization time. Utilization balancing algorithm. Next fit algorithm for RMA. Bin packing algorithm for EDF. Dynamic allocation algorithm. In many application, tasks arrive sporadically at different nodes. The tasks are assigned to processor as and when they arise. The dynamic approach incurs high RIM time overhead since the allocator component running at every node needs to keep track of the instantaneous load position at every other node. Focused addressing and binding. The buddy strategy algorithm, utilization balancing algorithm, there are two types. This algorithm attempts to balance processor utilization and proceeds by allocating the task one by one and selecting the least utilized processor. Objective to balance processor utilization and proceeds by allocating the task only one by one and selecting the least utilized processor. Maintain the task in a queue in increasing order of their utilization. Removes task one by one from the head of the queue and allocates them to the least utilized processor each time. Next fit algorithm for RM scheduling. This is a utilization based allocation heuristic. The task set has the same properties as for the RM uniprocessor scheduling algorithm. M is picked by user. Corresponding to each task class is a set of processor that is only allocated to tasks of that class. It is possible to show that this approach uses no more than n times the minimum possible number of processes. Pin packing assignment for EDF. Same assumption on task and processor as next fit algorithm problem. Schedule a set of periodic independent preemptible tasks on a multiprocessor system consistent of identical processes. The task deadlines equal their periods and tasks require no other resources. Focused addressing and binding algorithm. It uses dynamic allocations. FEB is a simple algorithm that can be used as an online procedure for task set consisting of both critical and non-critical real-time tasks. Critical tasks must have sufficient time reserved for them so that they continue to execute successfully, even if they need their worst case execution time. Every processor maintains two tables called status table and system load table. Status table indicates which tasks have been already committed to RIM, including the set of critical tasks which were pre-assigning statically, and any additional non-critical tasks that have been accepted execution time and periods of the task. Load table contains the latest load information of all other processors of the system. The surplus computing capacity available at the different processors can be determined. Every processor on receiving a broadcast from a node about the load position update the system load table. Since the system is distributed, this information may never be completely up to date. As a result, when a task arrives at a node, the node first checks whether the task can be processed locally. If yes, it updates its status table. If not, it looks for a processor to offload the task. Select a processor called the focus processor per second that is believed to be the most likely to be able to successfully execute that task by its deadline. The system load table information might be out of date. The overloaded processor as insurance against this will decide to send request for bits to other lightly loaded processor in parallel with sending out the task to the focused processor PS. This is to gain time in case PS refuses the task. The RFB contains the vital statistics of the task. It expects execution time, any other resources, requirements, its deadline, etc. The RFB asks any processor that can successfully execute the task to send a bit to the focused processor PS starting how quickly it can process the task. An RFB is only sent out if the sending processor PS estimates that there will be enough time for timely response to it. Buddy strategy. The buddy strategy tries to solve the same problem as the FAB algorithm. Soft real-time tasks arrive at the various processors of a multiprocessor, and if an individual processor finds itself overloaded, it tries to offload some tasks onto less lightly loaded processors. Assignment with precedence conditions. Algorithm that assign and schedules tasks with precedence conditions and additional resources constraints. Basic algorithm idea is to reduce communication cost by assigning to the same processor tasks that heavily communicate with one another. Underlying task model. Each task may be composed of one or more subtasks. The release time of each task and the worst case execution time of each subtask are given. The subtask communication pattern is represented by a task persistence precedence graph. E are also given the volume of communication between tasks. It is assumed that if subtask Si sends output to S2, this is done at the end of Si. Associated with each subtract is a latest finishing time. Thank you.